Welcome to lecture 21. In this lecture, I will be showing you how we can interface with Arduino Uno, one of the Arduino boards, very popular one. In the previous lectures, I have specifically shown you how we will be using with STM board, and here I will take you through the steps that are required to use Arduino Uno board, which is again fairly very straightforward. I will just show you some of the features of this board first, and then what are the steps that are required to actually interface with Arduino Uno. As I told you, I will be talking about Arduino Uno board, description about the pins that are available, and also an workout example for blinking LED. Although in this experiment I will not interface it, but in subsequent slides you will find how do we interface it with the board. Today in this lecture I will be specifically showing you the steps that are required to use Arduino Uno board. So what is Arduino? It is an open source computer hardware and software company. It designs and manufactures various embedded system boards and accessories, and one of the very popular board is Arduino Uno, okay, which is used by student community across the world to design various small embedded system projects. This Arduino IDE can be downloaded from this particular site. You can directly go there and you can download from that particular site. So what are the requirements? For STM32 boards, we have already seen what are the requirements that are there. Now for Arduino board, again the same way, this is the board in place. It depends on how do you interface, but the most easy way is like you connect through this USB connector along with your PC. So this jack is connected here and this jack will be connected to your PC or laptop, okay. This is how it is connected. This is the USB connector which is required, and the development environment. The development environment that are used is Arduino IDE, which looks like this, which can be downloaded from the website I have already discussed. Okay. So this is Arduino Uno, which is widely used open source microcontroller board based on Atmega 328P microcontroller and is developed by Arduino, this company. What it consists of? We have seen, we have already seen the STM board, right, in the previous lecture, how we can program. There 14 digital input output pins are available. Those are all Arduino compatible pins. So these are the following pins that are there: 14 digital pins and 6 analog pins, and it is programmable with Arduino IDE via this type B USB cable, which I have already shown you. It can also be powered by USB cable or by an external 9-volt battery. Let us say you have already dumped the program and you want it to run without the support of any PC anywhere. So how do you power it? You can do that using this external 9-volt battery, though it accepts voltages between this particular range, 7 to 20 volt. This board is the first in the series of USB Arduino board. Earlier boards you need to dump it through some other means, not through these USBs. But when this USB compatible boards came, in Arduino. This one, Arduino Uno, is the first of those kinds of board and the reference model for the Arduino platform. The Atmega 328P on the Arduino Uno comes pre-programmed with a bootloader that allows to upload new code to it without the use of any external hardware programmer. So, we do not need to have any external hardware programmer. Rather, if when we connect it, this inbuilt bootloader is already there. So, it communicates using the original STK500 protocol. This is a protocol that is used for this communication. The communication between this STK500 and the PC is done over this RS232 COM port. And this STK500 uses 115.2 kbps, 8 bit of data, 1 stop bit and parity. The PC should be set up similar for the communication to work. So, when two devices communicate with each other, if one device runs at a higher rate, other device does not runs at that rate. So, you need to have some kind of means of communication in between them. So, this device must know at what rate the other device is communicating. So, for that purpose this is required. So, this is the overall board. You can see I have already discussed about this power jack. This is the USB controller, USB port through which it can be connected. This is the Atmega microcontroller that is there. This is the digital power supply pins. This is the analog pins and these are the digital input output pins. We will be looking into when we perform experiment with these particular pins, this particular board. We will be doing couple of experiments with this board. So, there we will be specifically looking into the various aspects of these particular pins. So, what are the points that you need to remember for programming using this Arduino? The first and foremost thing is that you need to download the software, okay, the IDE. And for using the 14 digital input output pins, we need to know the following functions. One is pin mode, another is digital read for reading the input, digital write to write the value into the port. So, one is the output, one is the input functions during the programming. There are also 6 analog input pins, each of which provide 10 bits of resolution. We have already discussed about the resolution and other aspects of analog to digital converter. So, this is of 10 bit resolution. Once you download it, extract the downloaded zip and click on this arduino.exe. Then the Arduino IDE will get open, which looks similar to this. So, it says starting here. Okay. So, it will look somewhat like this. Okay. When you have already done with installing the IDE, which is fairly very straightforward, then when you open it, the IDE will open as like this. It call it as sketch. This is setup phase and this is the loop. What is the setup phase? The setup code here that we write is only run once. Okay. So, the setup section is widely used to initialize the variables, mention about the pin modes and set the serial baud rate, etc. When we will use other communicating devices like the GSM or Bluetooth, you need to specify that rate here. Okay. So, that must be specified. All those things must go in this void setup phase. The software only goes through this once and only once. The void loop section is the part of the code that loops back onto itself, and it is the main part of the code. The code that you write, let us say that LED will glow for some time. So, that part of the code will be put up in this void loop phase. So, this you must remember, setup phase and the loop phase. Now, I will take a small example to blink an LED, what we need to do. You have seen it in Mbed compiler, we need to include a header file, etc., etc. We will see what is required here, but the main phases that is required here are two. One is the setup phase. Here I am doing initializing, this is basically the initialization. We are making pin mode the 7th pin of Arduino as output. Set the digital pin 7 as output. This is what we are doing using this particular statement, pin mode 7 comma output. You can also do it as input, pin mode 7 comma input, okay. But this here we are specifically making it output because we want the LED to glow. Then the void loop. What we are doing, we are using a function called digital write, where the output port, that is 7, we are making it high. So, we are setting the digital pin 7 on high mode, we are making it on basically. Then we are giving a delay of 1 second. Here it is specified in millisecond. So, 1000 millisecond is 1 second. Then we do a digital write to the same pin 7 low, and then we delay it for again the same 1000 millisecond, that is 1 second, and this goes on. This is a loop phase, so this will go on running. Okay. So, this is a typical pin diagram. So, we are not using the onboard LED here, rather we are using, this is the Arduino Uno board, okay, and this is the 5 volt of that Arduino, and this is the LED, okay. This is the anode and this is the cathode. So, the anode end through a resistance is connected to 5 volt, we can see that, and the cathode end is directly connected to pin 7, okay. This is the circuit diagram. When the LED will glow, as this is connected to 5 volt, when this pin will have a 0 input, then only this LED will glow, okay. This particular LED will glow. So, what are the steps that are required here to do the needful? So, here we select this pin mode 7 as output, we write the program, okay, and then we select the Arduino board, okay. There are many Arduino board, but here we are using Arduino Uno. So, specifically you have to use that board from this particular list, okay. You see we have selected this particular board, that is Arduino Uno, okay. Next, select the port number. We can select this COM4 for this particular Uno. And then we press this upload button to upload it basically. Just a second. Yeah. So, this is the setup phase, this is the loop phase, and we press on the upload button to upload the program into it. One important thing, we haven't talked about hyperterminal, which we will be discussing in the next week. Arduino has a good feature that it does not require any external hyperterminal. The hyperterminal is inbuilt there. So, you go to tools and then you can click on this port COM3 Arduino /Genuino Uno and you will get this. So, whatever data communication you want to see, you can see it in this port. So, we will look into that later. This is one of the feature of Arduino. So, this is all about this Arduino board. How will you interface with Arduino board? You need that IDE, you need to write the code goes in 2 phases, and finally you have to upload the code. It gets uploaded into the device and then it is done. So, this is another board aspect apart from STM board. Okay. So, today I will be showing you now how do we connect an LED with the 2 kinds of board that I have already discussed. So, what I have discussed so far? I have discussed with you that how we will be working along with STM board and how I will be working along with Arduino board. Okay. So, both the boards has got some features which we have already seen. Now, we will be right away going to the interfacing experiments that we will be doing in this session. I have already discussed how the onboard LED will glow, right? We have already seen that. Now, I will be connecting another LED using breadboard with STM board as well as with Arduino board. So, let us see how we can do this. Okay. So, on the first go, I will first talk about breadboard. This is a breadboard through which we can connect various small interfacing devices and we can do small experiments. So, if you see how the connections are here, these lines are horizontally connected. So, if you see a breadboard, these are the lines which are horizontally connected. These are connected, this is connected all together, this is connected all together, but there is no connection between this and this. But there is a connection between these few points. And these are vertically connected. Okay. So, there are 2 lines we can see here, these are vertically connected together. So, from any point you can put either VCC or ground and then you can use and connect with other pins, maybe which is connected here or here, anywhere. Again, one thing you have to remember, there is a cut between here. So, this is connected, but this is not connected with this one. So, this is a separate connection, this is a separate connection. If you want to connect the whole thing, you have to make a wire from here till here. Okay. So, this is how the connection in the breadboard is. So, we will be doing the first experiment, that is with LED using this breadboard. We also require some jumper wires, these are some jumper wires which is required, and a resistor. Firstly, I will show you, this is the LED. See this LED. If you see this LED, you can make out that one of its leg is longer, another is shorter. I already discussed this in the lecture, but what does it mean? This is the anode and this is the cathode. So, the long leg is anode and the short leg is cathode, and current always flows from anode to cathode. Okay. The first thing that I will be that I will be doing here is that I will connect this LED with STM board. And the first thing again I will do is first I will check whether this LED is working fine or not. How will you check that? Whether this LED is working fine or not? What you can do, the anode with a resistance you can connect to BCC, and the cathode you can directly connect to ground. Okay. And then we will see whether this LED glows or not. Okay. So, let us do this experiment with STM board first. So, this is the STM board. So, this one is my anode, this one is cathode. So, I put it up like this, put it up in the breadboard like this. Then through a resistance I connect to this end of the breadboard, and from this end, which is vertically connected, I will put it to BCC. So, the BCC pin here is the fourth pin from here, 1, 2, 3 and 4. So, I put it there, and this from this point, from this point, that is the anode, I will connect it to ground, and I see that the LED is glowing. Okay. You can see that the LED is glowing. If I take it out, it is not glowing. Now, again I will put it up here, it is again glowing. Okay. So, if you can understand that, now you can make out that yes, this LED is a working LED. Now, what I will do is that I will connect the anode with BCC, but now I will connect the ground with digital pin D2. Okay. So, the digital pin D2 is here, this is D0, D1 and D2, the third pin from here I connect it. And now what I will be doing? I will be dumping a code into this board. Okay. So, for dumping the code, we have already seen what all are the steps that needs to be followed to dump the code into this particular board. So, that I will be doing. Okay. Now, can you see one thing? What is happening? The LED is glowing for 1 second and it is off for 2 seconds. You see, it is glowing for 1 second and it is off for 1 second, and this is repeating. This is in that while loop. Okay. So, this is in that infinite while loop where we have actually put up the code where the LED was glowing for 1 second and it is off for 2. Now, it is glowing for 1 second, again off for 2 seconds. So, this is how you can do programming with this STM board using a single LED. You can also make different various kinds of experiment with LED with few more LEDs. If you connect, you can make a counter that way. So, you can put another LED here, and what will be the counter? The counter will be first 0 0, then 0 1, then 1 0 and then 1 1. So, this can also repeat forever. So, there are various kind of experiments that you can try out doing with STM board. Now, what I will be doing? Now, I will be doing the same experiment with Arduino board. The code I have already discussed. Now, I will be doing the connection first with the Arduino board. This is Arduino Uno board. The functionalities I have already discussed. Now, I will connect it. The same way, this connection is straightforward. Now, I will connect this part with BCC, and this one with pin D2. Okay. Now, I will again use the Arduino editor that we have used for dumping the code. Okay. So, now the code is dumped and it is also doing the same thing. It is on for 1 second and it is off for 2 seconds. The same code we have written using the Arduino board and it is doing the same thing. Okay. So, you see that we have done two experiments with same experiment basically with two different boards. And please make sure to understand the connection. You see what connection we have made it here. These are the two legs, of the LED. One leg, that is the anode, is connected using this resistor, through the BCC. It is connected through this resistance. We have connected, and then from here we have put it to BCC, and the cathode is directly connected to one of the digital pin, that is D2. Okay. And what we are doing, we are passing through this digital pin D2 0. When we pass 0, this LED is glowing. When we are passing 1, this LED will not glow. Okay. So, this is how this works, this LED works. Okay. So, in this experiment we have connected a single LED to both the boards, that is STM and with Arduino Uno. You can try out other examples connecting a few more number of LEDs, and then you can make a LED counter in some way or the other, or you can try out with various other examples. We will be using this LED for some other things as well in some more experiments. So, we will be seeing that where we can use this particular feature of this LED. Thank you.